Look across North America today, you see highways cutting through plains, sprawling infrastructure, and wildlife that mostly keeps its distance. Animals like deer, coyotes, or black bears that easily hide in patches of remaining forest. Rewind 20,000 years ago, and that same continent vanishes. The cities disappear, the forests are replaced by vast expanses of frozen tundra, and there isn't a single human being in sight. To survive in this extreme sub-zero environment, biology prioritized one trait above all else: physical size. Large bodies retain heat far better than small ones, leading to an era of megafauna that grew to sizes modern land mammals simply cannot match. For millions of years, these creatures dominated the North American landscape, and then, abruptly, they vanished from the fossil record. All we have left of them are massive bones embedded in the dirt. These fragmented skeletons are the only evidence we have of a biological collapse that happened in a geological blink of an eye. To figure out what possessed the power to wipe out millions of giant animals across a whole continent, we have to understand how they actually lived. The undisputed anchor of this frozen world was the ultimate mega-herbivore, the woolly mammoth. Standing up to 4 meters tall at the shoulder, they possessed immense physical power. Looking at the skeleton, you can see the bone density required to carry those heavy, curved tusks, used to clear thick snow and ice to reach vegetation. As vast herds of mammoths migrated across the continent, their sheer body weight compacted the thick snow and soil beneath them. They trampled overgrowth, dispersed seeds over long distances, and acted as literal landscape engineers, maintaining the endless grassy steppes. The mammoth didn't work alone. They shared these plains with other massive grazers, including the giant bison, an animal that evolved specific anatomical traits to survive alongside them. You immediately notice its primary evolutionary defense. Those upward curving horns reached a span of over 2 meters, vastly wider and thicker than any living bison. These grazers survived on low-nutrient, frozen vegetation. By growing enormous digestive tracts inside massive bodies, they could extract enough energy to stay warm and power their heavy frames. Gigantism was a required mechanism for survival. While the grazers engineered the open plains, other animals took stranger evolutionary paths into the forests and brushland. Enter the giant ground sloth. When you see the skeleton reared up on its hind legs, its vertical reach becomes clear. In this stance, the giant sloth stood tall enough to strip leaves from high tree branches that modern grizzly bears could never hope to reach. But a landscape packed with immense, slow-moving meat sources triggered a biological reaction. Predators had to adapt to take down prey that weighed several tons. Short-faced bears grew long limbs for high-speed pursuits. Saber-toothed cats developed specialized, extended canines to slice thick hides. And dire wolves evolved heavy jaws to crush bones in packs. We know these brutal encounters happened because the evidence is perfectly preserved in natural asphalt seeps or tar pits. Heavy herbivores would get stuck in the tar, drawing in waves of specialized predators who would then sink into the asphalt right alongside their prey. This ecosystem was incredibly specialized. Massive prey required massive predators. But that high-stakes balance meant that if any single variable in their environment shifted, the entire food web would collapse. At the end of the Pleistocene epoch, the environment finally shifted. The continental ice sheets began a rapid, aggressive retreat. One explanation for the sudden collapse centers on the climate. As temperatures rose, the frozen grasslands the mammoths and bison relied on quickly melted into swamps and dense forests, destroying the primary food source they needed to maintain their massive body mass. Another explanation looks at the arrival of humanity. This theory suggests a newly arrived, highly coordinated apex predator hunted these giant animals faster than they could reproduce, eventually pushing them to the point of extinction. This chart maps out the timing of these events. You have a steep declining curve tracking the rapid drop in the megafauna population. Simultaneously, an aggressively rising curve for global temperatures appears, alongside a secondary curve tracking human expansion. Look closely at this intersection. The data converges so tightly, researchers still debate if climate, humans, or both delivered the final blow. Within a short geological window, the biological titans were gone. The North American continent was emptied of its colossal rulers, leaving behind the much smaller, modern wildlife we recognize today. But as the melting ice wiped out the giants, it also caused sea levels to shift, exposing a hidden landmass connecting Asia to North America. The beasts were dead, but the humans had arrived.